So in our last video, we had a bit of a discussion on what exactly was a support. We've set up the ability to be able to draw supports in their different forms, but beyond that, aside from making a few types, that's all we really were able to accomplish. And we kept coming in to the question, what's the difference between a support and a node? And so a node we were using to be able to generate, the endpoints of our beam element. And each one of these, if this is A and this is B, then this guy would have coordinates of some XA, YA, and this guy would have some coordinates of XB, YB. And we were using that kind of as the basis of our definition of a node. There wasn't a whole lot of other properties that we saw on this. Now, what we want to look at is, we started applying what would be more of a boundary condition kind of thing, which is kind of a mathematical term for constraints on a set of equations. And so, if now I have a beam that is looking like it has say a pin at A, and we have a roller at B, like this. Oops. It looks something kind of like that. Now, it's still technically a beam with nodes here, okay? And so we're going to define our boundary conditions as being some sort of constraint to our system there. All right, and so what happens is we can set up, and since we do most everything off of the left when drawing shear and moment diagrams, we're going to define a variable x that comes off of the A dimension here. And so what we'll do is the boundary conditions then are that at x equals 0, A is a pin. And then at x equals L, which that's assuming that L is that length, the length of the span of the beam, then B would be defined as a roller. So there are specific locations of, roller, there we go. Specific locations where certain things are known to happen. Now, more specifically, for a pin, the boundary conditions are that the deflection in the x direction is 0, the deflection in the y is 0, and theta, the rotation, is not equal to 0. Let's clean that up a little bit. A little better, okay? And for a roller, for a horizontal roller in this case, the boundary condition is that delta x is not equal to 0, but delta y is equal to 0, and theta is not equal to 0. Those would be the boundary conditions that will start to kind of happen relative to displacements, because we define a support condition as being a resistance to a motion on there. Now, one of the things that we want to kind of look at on our discussion is well, when we set up our supports, was it a node? Okay, well, technically, we want to be able to draw the supports a little bit differently, and to be able to use our default behavior of the node draw function that we defined last time. We were drawing nodes. Remember, those are the black circles with the white rings, and we'll show you those here in a second. But the supports were a little bit differently, and I wanted to be able to draw one or the other relative. I wanted to be able to show the node, and then we drew our triangle shape for a pin, and we drew our ball for the roller, and we even had one for fixed. And it didn't really capture what the node was doing on this. So what I think we're going to do is we're going to make a change to our support conditions, okay? Is that in order to be able to draw this, because we do have, if we look, we created an enum. That defined a bunch of support types. Okay, and so when we had our roller X, our roller Y, our free support. And so what I think we're going to do is we're going to add a field into, so if we kind of, let's see, what do I want to do? I want this guy. okay, that if this is my node class, oh, there it went. It took it forever to. There, I did one too many times. Okay, there we go. And so this is my node class. We needed an X, we needed a Y, and that's really all that we had. We had the ability, we had an index, which was its number when we created the node. But one of the things that we're having an issue with is that every time we draw something, we're creating nodes, and every time we create a node, we're indexing something that may or may not be needed in terms of the structural model. And that's going to require a whole lot of issues with sorting and later on as we start to kind of pull parts out and do our calculations. And so I want to try to minimize the amount of superfluous nodes that we're creating on this. So what I think we're going to do is we're going to add a field here that is, you know, something like a support type member field into this guy. And then we'll use that to store the enum for the type of support, and then that enum in the draw function, because remember this guy also has a draw method on there that we'll use the support type to dictate how he draws himself. And I think that's a better, more condensed way to do it. And this way, I'm assigning it's basically a property of a node as a support, okay, without actually making a whole new class. Now, I know we made this big spiel about creating, you know, supports and understanding what they're doing, but I think just as I was thinking about this after posting the last video, it's kind of like, I think this is a better way to do it. So we're going to make that change today. We're also going to go in and we're going to tackle some issues with some of the helper functions to try to make them more generic so that we could create a library outside of this program that could be used later on, that instead of using node numbers to create and draw our lines in our circles, we're going to actually use the coordinates. That'll be a minor change that we'll do at the end of this video. So that's the goal for today. So we'll get ourselves going. All right, so here we are back in our Visual Studio, and we're going to make those changes that we talked about. So we're going to first start off with our VM node class, which is where we were defining our X and our Y, and we had a couple of properties for pulling and setting things. And we're going to add a couple of fields into this one. The first one that we're going to add is going to be, get our microphone here situated a little bit. Okay. Is we're going to add a private, and then it'll be a support types, and then a member, and then we'll call this support type. Okay. The type of support as an enum. Okay. And so we're going to keep that in our support class. So if you remember, if we go over to support class, we defined a whole bunch of enums here, and so this will allow us to add a list, and then based on which one we choose, this will dictate how we draw. So what's going to happen is a lot of the functionality in the draw function for the support is now going to be moved into the node class, and he'll know how to draw himself relative to those pieces. Okay, and then and we'll just keep adding into this list onto different types of nodes. And eventually we'll get into nodes with partial constraints, or we can do any number of things as we start to set that. That's the whole point in all of this, is to kind of help ourselves. So what was a default node is these two lines. We'll now incorporate all of the others. So that will get us our support type. Now, we're going to come in and on our node constructor, we're going to add then a support types, and then support, and we're going to default this to support types dot, and then we're just going to default it to undefined. Okay, since we know when we create the node, we may or may not know the boundary condition that's on there. And so what we'll do is then as we construct our model, if we say lay in a node and put a beam, draw the beam that connects that node to another node or an element or whatever the case may be, and then I later decide that, oh, well, this node needs to be, a pin, I can go in and all I have to do is update this field and everything else is copacetic, and we'll be good to go. So all I'm going to do here then is going to do a min support type, and that's going to be equal to a support, and that gets us this piece. And so now we can create this. So even if I don't update any of my other node creations on this, now we can start drawing everything else. Okay, and so that's the first piece of the puzzle that we have. So now let's go through, let's bring this down a little bit. And we'll go back to our support case, and we want to grab, I think, pretty much everything. Yeah, we do want to grab everything here. Make sure I didn't go too far. And looks like I went one too far. Okay, so grab it there. Okay, and we'll copy all of that, and we'll throw this into my draw function here, which will get us our ability to draw stuff. And then these two lines that were left over from the default node, we can draw them into our default drawing. And then, let's see, let's move him down. I know we stubbed all this out last time. So this is all code that we had from the last time. And then we will put him there, and what we'll do is we'll have these ones that are undefined. Okay, is we'll have their cases, and they'll just drop through, and then as they drop through into the default case, which was our circle, and that prevents a lot of repetition of code. Okay, so if this works, and this is untested, so anything's possible. Let's comment all of that out. Okay, so now we don't have a draw function at all on this. We need to go in to these guys. Okay, and so if I take this out, we should be back to where we were 2 videos ago. Oops. Grab you guys, comment you out. And to shortcut for commenting a bunch of stuff is Control-K, Control-C, so that's all I'm doing on those. I keep forgetting that you guys don't know what I'm hitting on my keyboard. Whoops. Where do we? Oops. Did I miss? Oh, I missed a bracket on the switch. Yes, indeedy. All right, that'll get us that. Which one are you blowing up? Type for namespace. Oops. Missed it. Always those closing parentheses always get me. Okay, so, all right, let's take a look. Okay, and so now we're back to where we were on what we were drawing before. Now, let's go through and say for our first node, let's do nodes 0. So we'll take the first one that's on there, and we're going to set it, that's our draw. How do I want to do that? 0.x. Can I do that? It's been a little while, so I got to remember what I did. Go back up into here. Support type. We need a getter and a setter. That's why I can't see stuff. Let's do a public support types, and then we'll call those support type, and then we'll do a get, and that's just going to return our support type. And again, I know we could be using defaults, but this will allow me to just, I prefer to do it this way. It's a little bit of extra typing, but this way I know explicitly what I'm doing, and then if I need to change something in how something is set or got, or if I need to utilize the notify property change ability, I can do it here, and I'm set up for it on here. And again, we're not doing much in the way of error checking at this point, but we'll do a set and then a support type. Okay, is equal to our value that we pass in. Okay, and then that should be able to get us there. And so then we will also change this. So instead of accessing the private guy, we'll use the getter and the setter here. Okay, so that should get us that. Okay, so that will work on that. Let's see, now if I go back over to here, so our nodes 0, that's a list of our nodes. Dot, why am I not? Type equals types dot, and we'll make this guy a pen. And so then when I draw him, why is it? Do you not know? All right, what are we doing here? Where's my nodes? A list of drawing objects. So let's try a VM node temp equals a VM node of our nodes 0. All right, and then so we made a copy of it, and then go temp dot support type, there it is. And then I can take this off, and then we're going to define that as a pin. Okay. Yeah, so let's see, will that solve our dilemma? And so now you can see that it's now drawing it as a pin on that case because we've updated everything. All right, so that's pretty cool. And we've basically accessed everything. Yeah. So yeah, it's a little bit kind of a weird construction here. There's probably a more elegant way to do that, and I will look into that, but that solved my problem on that. So all right, so we can do all this. Let's go in, let's just say, just to test that the others still work. And if I do VM node temp2 as a VM node of the next guy, like that, and then I can do modes. Let's Control C, Control V, and then we'll make a 3 as the next one. And then we can do temp2 support type is support types. So let's make him our roller X, and then we'll do temp3 dot support types dot, and then we'll make that as a fixed horizontal, because those are the only ones that we have defined currently. So that's kind of our test, and we can take all of this out. Okay, and I think we'll be happier with doing it this way. Okay. Okay, and so you can see there are the 3 that we created, and they're still just technically nodes, but it has to do with the way that they're being rendered out when they're being drawn. Now, like I said, we may decide that we want to put a circle in here or do something like that, but that's, you know, and again, we're going to work on the graphics, and you can see that our blue circle is a little high, so we can drop that down if we need to. But for now, the functionality is what we're after as we start to try to do this. So anything that doesn't have a specific support type defined gets drawn as a regular node, and then everything else gets its special appearance, if you will. Because in the end of the day, the way we draw it doesn't really matter. As long as the node knows that he's a support, we should be able to work on that. So cool. All right. So that gets us that. All right. The next issue that we want to look at has to do with, not that one, our node. So we've now taken our support. So we've got a support class in here with our enum, VM support. We can now take all of this out. So we'll just have kind of an empty class that's not going to do much. I do need to have a probably public draw that does nothing. Public void, and then draw. And that will get us that, and that's our stub for what we have happening there. And it kind of resolves that issue of, well, is this a supported node? It answers that age-old question. You know, not since the dawn of man have people been pondering the existence of life and whether or not a supported VM diagrammer is a node or not. And now we've resolved that issue. All right, so that will be kind of how we do that. It's a lot cleaner, I think, and a better way to do it. Okay, yeah. So now if we go back into our draw functions, the other problem that we have is now we're drawing based off of nodes. Okay, and so you can see, and every time we create a node, remember the entity in the what will be a database, or in our case, our list of nodes, gets an index number. And even though I only use it once, it's creating an index number, and it's just constantly adding those things. So what we want to do is go in, and we want to kind of see if I can get this line. It's also a memory management issue because I'm creating stuff that isn't needed over and over. So we'll pull that out. Instead of creating an object for it, we'll just use the numerical value, because that's all it's doing, is it's just basically crunching off of what it knows its x and its y point are. So the first thing we have to do is we need to go into our into our position. And I think our circle function is fine because it's doing x and y, but this draw line function, which is this guy, is an issue, because now instead of doing x's and y's, which seems to be more appropriate as a general helper, is actually using a VM node, which makes it specific to this application. All right, so let's go in and look at our drawing helpers and take a look. So here we're using x and y, here we're using x and y. It's this guy right here that we need to kind of change the signature of a little bit. Now I could make a helper where it works this out, but let's go in and say, so we'll do a double, and we'll say SX, and a double SY. That will be our start x and y nodes. And then let's do a double EX and a double EY there, and we can get rid of the nodes here. We'll have to update a couple of spots where we call the function, but that's really not that big of an issue. Although technically, we could leave it. How do I want to do this? Oh, I just wiped it out. Let's copy this and make a. Okay. But if I have the nodes in there, then he's bound. No, I gotta redo. View, can I redo? Edit, redo, Control Y. Okay, that got us that. Let's pull this guy out. Let's just do it right. Bite the bullet now, so I don't have to deal with it later, right? Okay, so that will get us there. And so then my start X is now SX. My start Y is now SY. This is now EX. And then the ending point is an EY. And that will get us that one, so we're good on that. And that's more in line with what we were doing with all of these others, where I was giving coordinates on the screen to draw stuff, because it doesn't care that it's a node that it's drawing. It just wants to know, where do I draw my line? Between what points? And so I think this is the better way to do it. We'll take this. Can I put all of the params back in? Update. Yes. Okay, the endpoint X coordinate. Let's go param. This is our endpoint Y coordinate. And then a param SX. That's a start point X coordinate. And I know it seems like a lot of extra work to do these comments, but I find that it helps me remember, especially with the IntelliSense. Whoops, should have used the stub out method, but I didn't. Okay, like that. And this is our start point. Start point Y coordinate, and that should be an X coordinate, not a C coordinate. That gets us that, and then we'll define our param and our stroke, and that's the color of the line object as, and then we're going to do a C also, or C brush, and that will get us that. All right, and so I think with that we're okay. And it does have returns the shape object. Okay, right. And so that solves our draw line problem. All right, so now we just got to update what we have happening here. All right, so now you can see that we've broken down in the bottom of this. We've broken all of our calls to lines, but it's only 6 locations, so this isn't a big deal. So let's go to the first one. And so everything else is kind of, so we're going to do let's see, are we pulling? So let's make this a double start X and a double start Y. Oh. So we'll call that our value there. Okay, and so this is start X. This is now start. And so you can see that by labeling, by that we've now updated the signature, and that's what we're working on here. So start Y, and I can now delete this guy, and then I can come in here. And it's just cleaner. And like I say, sometimes it's kind of the process that you go through is that you write something, and that's the way I tend to write is I just get it working and then think about what you've done. And as we get faster and better at this, we can eliminate some of these items, but it just feels better doing it this way. Okay, and then this becomes an end X, and then we're going to pass it end Y, and now that one works. And then we go in, and it's going to be a lot of the kind of the same things. I'm going to save my math functions though, so we'll just double, and we can delete that. And then we want to kill this one. And you'll be a double, because everything's the same. It's all the math is just where are we doing the crunches, and this is the better way to do it. So that's our oh, I missed one. We've got to get our insert. So let's do a double insert X, and that's going to be this dot X. Okay, and then do a double insert Y is this dot Y plus the offset. So all I've done is I've basically copied the parameters I was passing into the node creation. Gets us that. And then this guy is just insert X. This guy is insert Y. This guy is insert X. And this guy is our insert Y there. All right, that solves that. More. You can see I made so many useless nodes when I did it. Double base start. Let's call that X. And then put a double base start Y. And you are start X. And you are start Y. And again, we just killed another node. That's always good. So those are our points. And then we got one more down here. You're an X, you're a Y. Can I? Used to be a way I could type multiple lines at once. I'm going to have to look up at the tricks for that again as well. I thought it was Control and Alt Shift or something, but anyway, not a problem. We'll do it the old-fashioned way, and we'll work on our speed of drawing. Okay, and so now we're going to do start X, start Y, and then insert X, insert Y. You can see this real quick. It comes together. Minor change that I think we'll be happy that we did later on. Insert Y. And then you're an insert X. Insert Y. Whoa, hold on. I got ahead of myself. Watch what you're doing. Undid. Okay, so here we are. Insert X. Insert Y. And then we're doing insert, and so we're doing insert X. Insert Y there, and then we're doing end X, end Y there. And then this one is index, end Y, and then start X and start Y. And there we've eliminated five node creations for every time I draw a line. So that's a lot of nodes that we were generating. And so base, start Y, oops, start Y, there we go. And then base index, base end Y, like that. So there's 5 of our line functions, and the other one's got to be down in the roller. Trying to see if I can just copy and paste. Start X, start Y. I think if I copy this, the only difference, Control C. Index. So we'll copy those. That's a minus. And then we were doing it at, what, 3.0 as our factor, 3.0. And I don't need the start guy anymore. And then I do need these guys, though. Let's grab the doubles. And there's no offset on that. And now it's just a couple of quick calculations instead of creating memory. So it should even speed up the, if we had a bunch of nodes, it would speed up the process of those. Index and Y, and I don't need any of that. There's that, and then we can do start X, start Y, and then do end X and end Y. And I think that resolves also. If we hit start, cross your fingers. Oop, where did we blow up? Drawing. That's our beam, so we need this dot start dot X, this dot start dot Y, and this dot end dot X, and this dot end dot Y. I don't understand why it didn't show up on the IntelliSense until I went to build it. Let's clean our solution and let's rebuild. Right. And you can see now we're back. Oh, no, we're not. What did I do? We lost our fixed in our draw function. So we'll go back to our node function, fixed horizontal. Because they are exactly the same point. So they actually be the same. One of these needs to be a minus. Minus, there we go. There it is. So that's the problem with copying and pasting code. Sometimes you miss something. So, all right. So I think we're back in business there. Okay, so we've kind of cleaned that up a little bit. Feel a lot better about this. Now, obviously, well, we didn't create nodes. We were just assigning, making copies of stuff, but that's kind of where we're at. So we have the ability now, you know, so let's do create test support conditions there. All right. So I think that's kind of what we wanted to do on this. It also solves the dilemma of how do I distinguish between these? Because again, it's just a matter of drawing. So so we can keep our nodes and beams separate. I don't mind doing that because we'll work with those a little bit differently. And the beams will reference back to the nodes, so that's fine. And then our nodes, we're just, the key points in our program, we're just throwing those all into this list of drawing objects, if you will. And that's kind of a bad label, but that's what I think we're going to work on. So, all right, so I think that's what we have for today. Fairly short one to make these changes to get things going, but I think that solved our problem. Make sure that we can still click and add nodes. Yep, still add default nodes because they aren't being defined as anything. And eventually what we want to be able to do is be able to, you know, like highlight this node 19, and then maybe from a drop down or a right click, I can say, oh, make him a support. And then when we do that, it will assign him, and then he'll change immediately upon having that assigned just based on the way that he's being drawn. But that's what we wanted to be able to get to. So that's good. So in the next video, we'll get back into actually trying to draw a simple beam. We'll probably get rid of a lot of this default boilerplate test code and start making it where I can create a simple supported beam and then start setting ourselves up to actually be able to start doing the drawing of the graph and maybe even working on some of the calculations. We'll have some math functions that we need to pull in, and I haven't decided if I'm going to try to write those functions by hand or if we're going to try to, you know, implement some sort of mathematics library. Kind of have to do a little bit of research on that, but we're kind of back to where we are, and this is the better way to set this up going forward. The code's a lot cleaner, and we're not creating as many nodes. This creating a lot of extra stuff that really don't need to be creating. This is a much better way to do it. So anyway, that's all we have today. Thanks for coming out. We'll see you guys in our next video. So ciao. Have a good evening. Bye.